So to get the derivative of radical, logarithmic, and exponential functions, we let u be any differentiable function. And we just use u prime representing du over dx. So ibig sabihin dito, kapag radical, pag nakita natin yung radicand that can be differentiable, gagamitan natin siya ng chain rule. So kukunin natin ang derivative nun. Also, the logarithm of a number, tapos yung u na to is differentiable, get the derivative. And when this is ln of u, okay, take note that u and u prime are not the same. Okay, and u here is differentiable, so kukunin natin. So we have to multiply that to au ln of a times u prime. Now let's have an example. In number 1, makikita natin dito na this x squared plus x can be our u here. So u is equal to x squared plus x so ang mangyayari dito, magkakaroon tayo ng the derivative of cube root of u. Okay, so what will happen on this case? Remember that our rule for radical is you have to get the index, then cube root of the index u, then 3 minus 1 index minus 1. Now multiply that to the derivative of u. So the derivative of u here, or u prime, is 2x plus 1. Okay, now we substitute that, so we have 1 over cube root, 3 cube root of u raised to 2 now, because 3 minus 2 is 1, times 2x plus 1, that is the derivative of u. Therefore, we now have 2x plus 1 times 1 is simply 2x plus 1 over 3 cube root of, now let u be equal to 2x squared. Okay, balik na natin ang value ng u, that is x squared plus x, so we have x squared plus x quantity raised to 2. So this is our answer. On this next example, we let u be equal to cotangent x, and the derivative of cotangent x, or let's say u prime, is negative the square of cosecant x. Therefore, this will become the derivative of the fifth root of u. Okay, and u is cotangent x and it's differentiable, so we have, using the radical rule, 1/5 fifth root, okay, fifth root of u raised to 5 minus 1, then multiply that to the derivative of u, which is negative cosecant squared x. We now have negative cosecant squared x over fifth root over 5, fifth root of u raised to 5 minus 1 is 4, then substitute that u, that will be cotangent x quantity raised to 4. So that will be our answer. So here in logarithm, we will let u be equal to 5x. So we have u that is equal to 5x. So this will become the derivative of logarithm of u to the base 3 is now equal to 1 over, okay, so we get that will be 1 over u ln of the base, which is 3, and multiply that to the derivative of u. So the derivative of u here is equal to 5. So that will now be equal to 1 over u ln of 3 times 5. Now, palitan ng u ng 5x, so we have 5x ln of 3 times 5. But we can observe here that we can cancel out 5 here. So our answer will now be 1 over x ln of 3. Okay, but can you observe also that this can be written using the product rule of logarithm? That is also equal to logarithm of 5 base 3 plus logarithm of x base 3, wherein the derivative of this constant is simply 0, and the derivative of this will be our answer, and that is equal to 1 over x ln of 3. So they are just the same. So take note, you just need to recall all the properties and you can just simplify it quickly with the property. So next, this will be our u cosine x. The derivative of this u prime is negative sine x. Changing cosine x into u, so we have the derivative of logarithm of u is equal to 1 over u ln of 10. This one is a common logarithm. Multiply that to the derivative of u, which is negative sine x. Ngayon, palitan ng u ng cosine x, so we have 1 over cosine x times ln of 10 times negative sine x. So multiply, so we have negative sine x over cosine x times ln of 10. So we can factor that out, so we have negative sine x over cosine x times 1 over ln of 10. And since tangent x is equal to sine x over cosine x, then we can just replace that. So our final answer will now be negative tangent x over ln of 10. See, we need to replace this into negative tangent x. So in this case, this will be our u. U is equal to 5 raised to x, and the derivative of that is 5 raised to x, ln of 5. So this will now be ln of u. So the derivative of ln of u is 1 over u times the derivative of u. So we now have changed u into 5 raised to x, and the derivative of 5 raised to x is 5 raised to x ln of 5, and it is obvious here that we can cancel out 5 raised to x. So our final answer will now be ln of 5. Also, you might as well remember the rule of power in logarithm. Ln of 5 raised to x is actually equal to x times ln of 5 using the power rule, and that is simply ln of x when it comes to the derivative of that. Therefore, that must be ln of 5, because the derivative of x ln of 5 is the constant ln of 5. Now compare them, they're just the same. So in this case, we let u be equal to 2x, so that we will now have the derivative of e raised to u, and that will now be e raised to u times u prime. The derivative of u is simply 2, so and derivative of e raised to u, change u into its equivalent, which is 2x, and multiply that to the derivative of u, which is 2. So our answer is 2e raised to 2x. So in this case, we let u be equal to sine x. So u is equal to sine x, and the derivative of u is cosine x, or the derivative of sine x is cosine x. So this will now be written into the derivative of 3 raised to u is equal to 3 raised to u ln of 3 times the derivative of u. So substitute u into sine x as given, and the derivative of u is cosine x. Proper writing, that must be cosine x. So our answer will now be, you can just enclose it for you not to be confused. So ln of 3 times cosine x times 3 raised to sine x. So in this case, we have x cubed plus x let that be our u, and then to get the derivative of that, we use the power rule, so we have 3x squared plus 1. Therefore, this will now be the derivative of 7 raised to u is equal to 7 raised to u ln of 7, the rule of exponential, times the derivative of u. Substitute, let u be equal to 7 cubed, 7 raised to x cube plus x ln of 7 times the derivative of u, which is 3x squared plus 1. So our final answer will now be, you can separate the constant, times 3x squared plus 1 times 7 raised to x cubed plus x ln of 7. Remember that you don't exactly need to expand this because it factored out would be better. Now we have 6th root of 4 raised to x. This 4 raised to x will serve as our u, and the derivative of that is 4 raised to x ln of 4. So this will now be written into the derivative of the 6th root of u. And using the radical rule, we have 1 over, copy the index, and 6th root of u raised to 6 minus 1 times the derivative of u. And that will be equal to, let u be equal to 4 raised to x, so 1 over 6, 6th root of u raised to 5, and that this will be 4 raised to x, quantity raised to 5, times derivative of u prime is 4 raised to x ln of 4. So we now have our answer, 4 raised to x ln of 4 divided by 6, 6th root of, 4 raised to 5x. There are also cases wherein the value u is also differentiable using the chain rule. It's like this, u is equal to ln of 3x, and the derivative of u is 1 over, take note that this is also differentiable, this is equal to 1 over 3x times derivative of 3x, which is 3, so u prime is equal to 1 over x. Now in this case, this will now be written into the derivative of 10 raised to u, and that will be 10 raised to u ln of 10 using the rule of exponent times the derivative of u, and that will be 10 raised to ln of 3x. We substitute now u ln of 10 times 1 over x. So our answer will now be 10 raised to ln of 3x ln of 10 over x.